Good afternoon, I'm Cherry. Today we have a series of use cases to show you. And before we proceed, I would like to give you an introduction of our test bed. And our test bed is called Smart Mobility Test Bed. And this test bed is based on the IEEE 802.11b standards and IEEE 1609 standards. And with these standards, we can have this vehicle-to-vehicle communication and vehicle-to-infrastructure communications. Okay, and we have a cooperative communication with other vehicles. So now I'm going to communicate with my colleague's vehicle over the Facebook call. So this is my colleague Calvin, and he's in the supporting car. And later we will use this car to show you the use case demo. And this is by the 11P, and this is the internet access, and this is the Facebook call. And this internet access is given by the 11P links through the V2X network, not by the cellular network. And our test bed now have the inter-RSU handover support. So we can now give the internet access to every vehicle on the road while they are on the move. So you can see here on this UI, our car is a green color icon. We are now going to show you a cooperative intersection use cases, and this use case is the safety use case. And we will be going to that intersection in front of us, and this is my colleague's vehicle on the slope on that other direction, and we will show you the collision warning alarms. And we are using the roadside units. If that is on your right side, there is a pole near the intersection, and that roadside unit is broadcasting the map message. So it is giving us the geographic information. With that message, we are able to know which lane we are in. Okay, and we have the onboard unit here, and my colleagues also have the onboard unit on his vehicle. And these vehicles are now broadcasting the basic safety message. So upon receiving the basic safety message from my colleague's vehicle and the geographic information from the roadside unit, our OBU will be intelligent to compute if there is any potential danger at the intersection. Okay, Calvin, are you ready? Sorry, can't hear you.
Can you warn us there's a vehicle coming in?
Okay, we'll wait for you. Let me know when you are ready.
Okay.
We just want to make sure that there is no blockage in between us because this is the demo, so. Yes.
We are good to go.
Okay. Correct.
You have somebody walking across the road, is it?
Yeah, 2 persons walking across the road. Just wait for a while.
Okay, so
I think we can go now, right? Can you? Let's go.
there's another car,
Oh,
sorry.
I'm going.
Okay, we can go now, Terry.
Okay, let's go. So that is our supporting vehicle just now, and because of the message that we received from my colleague's vehicle, the basic safety message and the geographic information coming from that roadside unit, we are able to know about this potential collision danger at the intersection ahead of time. And now I'm going to show you another use case, which is the roadside alerts. And you can see there is this roundabout icons at this location. So you can physically see the roundabout at your location here. And at At this roundabout area, we have a roadside unit, and that roadside unit is broadcasting the message about this roadside alert, so the driver can know about it much earlier. And this type of alert can be periodic or can be dynamic based on the event trigger. And next, we are going to show you the emergency vehicle alert relaying. So in this use case, just now my colleague vehicle will now be working as an emergency vehicle, and it will send out the emergency vehicle alert when it is on duty. And because this message is very important, so we like to extend the coverage of this message to even farther vehicle, farther distance. So how are we going to do this? Is by having a relay station, a relay vehicle, and it will be your left side. In front, there is a smart mobility dashboard car, a red color car, and it is actually a vehicle will be working as a relay station. This car. And this relay station, also can see from this UI, the black color car, will be relaying, rebroadcasting the emergency vehicle alert message received from the emergency vehicle. So long before you can see this emergency vehicle car from your UI, you will know the presence of the emergency vehicle in about 200 plus meter away by having this relay station. And when that vehicle is approaching very closely, when it comes into our communication range, it will become the direct messaging from that vehicle. So with this feature, we can extend the coverage for those special purpose messages like the emergency vehicle message. And now it is about to pass by our vehicle from our right side. Yeah, that's the one. Just now sending out the message. And we are now approaching to a car park. And in that car park, we have a use case called smart parking solution. And we have a roadside unit in front of the car park entrance. For the detail of that use case, I will give you more information on our way back. And you can see here there is a car park icon, which is telling you that there is a car park in front of you. And this message is actually coming from the roadside unit from this lamppost. And now we are going to show you a smart intersection. And we are going to show you how the 11P signal can be blocked because of the buildings and obstacles. And how can we prevent this type of blockage by having a relay station. And this will be shown you at the intersection. And you can see there is this car icon, red circle icon. And actually it represents a vehicle. And there is this building here, and this building is actually blocking us the 11P signal coverage. Actually, this car is just right beside this building, and we don't have a visibility to the car. At the same time, we also don't have the communication because of this blockage. And we are able to know the presence of the vehicle by having a relay station over there. You can see there is a relay station text over there written, and there is a pole, and on that pole we have a roadside unit, and that is rebroadcasting the basic safety message coming from the other vehicle. And now you are going to see that hidden vehicle from your left side, just right in front of you, the smart mobility Tesla car in red color. We do have a onboard unit. It is inside the building.
This is the one.
This is the one. And especially to improve the road safety, we are relying on this type of cooperative communication. But as you can see here, the 11P signal can be definitely blocked because of the high-rise building and terrains. So this type of thing can be really dangerous at the urban intersection where there are many tall buildings alongside, right? So we can apply this type of relaying feature at the urban intersection area to prevent any potential danger. Because we need to receive the message timely. If we lost the message, or if there is any delay, we might not know the situation is happening right in front of us. And soon we are going to show you a smart traffic light use case. And we still have quite a distance to the smart traffic light, so I will give you background information about it. So this smart traffic light is implemented by our smart mobility dispatch teams. And we have a roadside unit next to the traffic light. And this roadside unit is controlling the traffic light. At the same time, sending out the signal phase and timing information. So when our vehicle, the onboard unit here, comes into the range of the roadside unit, we will be able to receive the signal phase and timing. And the driver can adjust the driving speed, and we can also adjust based on the traffic conditions on the road. So for this smart traffic light use case, we will show you a priority signaling feature. And for this priority signaling feature, we are going to use a subordinate vehicle also. And that is just right behind us, our emergency vehicle. And that vehicle will send out the emergency vehicle alert when he triggers, when it is on duty. That is just right behind us. And we are now approaching the traffic lights. So there is a traffic light icon here on the UI, even before you can physically see the traffic light in front of you. And that is now in the red color. And you can see the traffic light also in front of us. You can see the 11 bit signal can bring you earlier message, right? And now it is in the red color. As you see, the emergency vehicle behind us is giving the emergency vehicle alert message. So the roadside unit is on your left side, this Lambo. We have a roadside unit mounted on top of it. And that roadside unit receives the emergency vehicle alert message from that emergency vehicle. Upon receiving it, it will change the traffic signal in favor for the emergency vehicle. And once that emergency vehicle passes by, it will go back to its normal signaling cycle. So that is how we can deliver this type of features to the special purpose vehicle. And you can see there is another traffic light, and we are now on our way back to the main executive center where we started our demo. You can see the traffic light because of this building and the blockage here. The 11-bit signal can bring you closer, and now it is in the green color. And it is now giving us a warning that if we are maintaining this speed at this location, we might be the red light. And of course, we are not moving very slowly, and this might not be very quite realistic, right? But if you are in the real drive, usually the driver like to speed up and beat light, right? And it might cause the collisions at the intersection. So this is now giving us that red light violation warning for those high-speed drivers. And we are now approaching a T junction. And you can see there is a stop sign here that we can see it physically with our eyes. And now this V2X technology, the 11P, is giving you this stop sign ahead. And especially when your visibility is blocked due to the weather conditions, even when the physical sign is damaged, but you will know it. And we have a roadside unit just near the T junction, and that is giving us this type above roadside alerts. Okay, we are now approaching to the car park, and in that car park we have a smart parking solution, and our test bed collaborate with the smart parking technology, and we have the car park sensor installed inside the car park at each parking lot. So whenever there is a vehicle occupy the parking lot or free at the parking lot, that sensor in that particular parking lot will update the information to the base station, and that base station is also installed in the car park. And later the base station will then update the message to the cloud server, car park management cloud server. And our backend computer in our data center will periodically pull the message and then update the message to the roadside unit. And we have a roadside unit just right in front of the car park entrance. So when we come near to the range of that roadside unit, you will know about the available parking lots. So in front of you, at your left side, actually it is a car park, basement car park in NTU. We have many car parks, but for the visitors like you won't know those car parks, and even more like you won't know the parking lots. And here with the sensor technology and the V2X technology, we can tell you the different categories of the parking lot available information. We have normal, we have reserve, we have accessible, we have electric. So as you can see, there are 4 different categories of the parking lots from that car park, and with the RSU just right in front of us at your right side, you are able to know about it. So next I will show you a demo which is called secure communication. So in this use case, it is a security feature. It is about a security feature. So you will be having another supporting vehicle, and that supporting vehicle is actually from your left side, just right in front, the smart mobility display red color car. This is the one. And it is sending the emergency vehicle message. So we can know that this is the fake emergency vehicle. How can we do this? It's based on having the security feature introduced into our test bed. So our onboard unit in the test bed have the security certificates enabled. So when this onboard unit receives the message from those types of vehicles, it can check whether this is the authenticated vehicle or just a fake message. So we can prevent any unsecure communication over the 11 buildings by having this type of security feature. So that will be the end of today's use case demo. Thank you.
Thank you.
Before we arrive our NEC, I just want to give you more information about our deployment status. So we have already deployed about 35 roadside units in our test bed. So now it is giving at the 11P campus-wide coverage. And we can, as I mentioned, we can do the RSU handover support over the 11 buildings. And as for the onboard unit, we have about 28 OBUs. And we install it on the campus shuttle bus and the campus security cars and the staff cars, faculty and staff cars. And alongside with the roadside unit, we have about 82 video cameras. And with that, we can do the real-time continuously collecting the video feeds. And with those video feeds, we can do the R&D activities. And we actually did several use cases related to that video use case. And I'm not sure if you have visited before here. We have the pedestrian user crossing on the pedestrian, and we have a video camera taking the video feeds, and if there is any pedestrian detected, it will inform the backend, or the backend can pull the information, and then it will later tell the roadside units nearby and tell all the car in the range that there is a pedestrian. So we have already done all those use cases with the video. If you have any questions, let me know. You can also approach my colleagues at the booth.
Thank you.
Thank you for coming.
Nice demo.